Hello everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम लोग जो डिस्कस करेंगे वो डेटा वेयर हाउस एंड डेटा माइनिंग की क्लास है, जो कि क्लास नंबर 6 है। ऑलरेडी हमने 5 क्लासेस कर लिया है, जिसमें अगर हम बात करते हैं तो हमने यूनिट 1 एंड यूनिट 2 एंड एज वेल एज यूनिट 3 होपफुली आज के क्लास में हम कंप्लीट कर लेंगे। एंड फर्स्ट ऑफ ऑल इट्स अ ह्यूज रिक्वेस्ट फ्रॉम माय साइड टू ऑल द व्यूअर्स, प्लीज गो थ्रू विद द सब्सक्राइब button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Let's going ahead. Last topic जो हमने किया था वो integrations of data mining and system with the database system हमने किया था, but in this today's class we'll start with the data processing, data pre-processing. First I will just let you know some of the things related to that what we have to discuss in this class, then we'll go ahead with the further one. In the data pre-processing, we'll discuss about the real-world data that contains the noisy, missing, and inconsistent data that due to the typical huge size, and these data are pre-processed to eliminate these missings and noisy data. That the mining of the processed data improves the efficiency of mining results, even though which include the data cleaning, data integration, data transformation, data reduction, that we'll discuss in a detail. In sort of data cleaning, if I'm talking about, with that fill in the missing values, that smooth not noise, and that correct inconsistencies of the data as well. And the approaches, if I'm talking about, there we have missing values, and that is the missing values that are filled with appropriate value or ignoring the values. That the method of the missing values that we'll talk about is in the detail here. That is or ignore the tuple and then fill the missing values manually, use the global constant to fill, use the attribute mean to fill, and of course that is use the most probable value to fill as well. Other than that, if I'm talking about here, so that is comes under the noisy data, and where there are the random errors or the variance in the measured variable, and that the data is smoothened out to remove the noise, and methods for the data smoothing as well, which is coming under the binding. That is binning in that the smooth asserted data, that value that according to its the neighbors values around it, and the regression that is comes under the noisy data, which is your the terms of it, that the smooth and the sorted data that value accordingly to its the neighbor value around it, and as well as with the same reference towards it. Another one is the clustering. In the same case of the clustering here, that is in the terms of the clustering, is that similar data are organized in the same group, and where the second one we'll talk about is your data integration. That is it combines the data from the multiple source to from coherent data stores, and data that is data transformation, which converts the data into the approaches forms for mining as well. In this, the approaches, if I'm talking about the approaches here, so here that the approaches we find it out is your that is aggregate smoothing, aggregation, generalization, normalization, attribute constructions, and data reductions as well. Where in the same case for the smoothing, that is that removes the noise from the data, aggregation, that summary or the aggregation operation that are applied to the data, and this is used for constructing the data cubes for analysis of data at multiple granularities, and in generalization, that low level data that are replaced by a high level concept through the use of the concept hierarchies, and the normalization, that attribute that the data are scaled so as to fall within a small specific range as well, specified range as well. And attribute constructions, which where that new attributes are constructed or added from the given set of attribute as well. And in the terms of the data reduction, which is it is used to obtain the reduced representations of the data in small values by maintaining the integrity of the original data as well. Now we'll talk about it in a detail here, and that is comes under in it. What do you mean by a data pre-processing? Data pre-processing. In the data pre-processing here, that real-world databases are highly susceptible to noisy, missing, and inconsistent data due to their typical huge size. And with the same references, this missing is your comes under in it, and that is this missing or a noisy data is present in the database, and because that the data are collected from the multiple heterogeneous sources, and the noisy data that may occur due to the human or a computer error occurring that at the data entry, errors during the transmissions, or due to the technology limitations as well. In the incorrect data that may result from the inconsistency in the naming conventions, or the data code that is used, or inconsistent formats for the input fields like data, low quality data containing the noisy or missing values that can lead to low quality mining results, and hence the data are pre-processed in order to improve the quality of the data as well. And these processed data that can be used for data mining, and hence it improves the efficiency and ease of mining process as well, which comes under the data pre-processing here as well. Let's go ahead. So now we'll discuss about that term data cleaning with a suitable example that has been asked for 5 marks as well. And then we'll start with what do you mean by a data cleaning, and what do you mean by the cleaning of data, and explain the important types of data cleaning that has been asked for 5 and 10 marks. So let's go ahead to discuss an important topic here. In the cases of the data cleaning here, that what we talk about it. And in the data cleaning, that means to clean the data by filling in the missing values, that smoothing the noisy data, and identifying and removing the outliers, and removing the inconsistencies in data, and sometimes data at a different level of the detail that can be different from what is needed. For example, you need the age range of 20 to 30, and 30 to 40, and 40 to 50, and the inputted data that contains the birth date, and the data that can be cleaned by dividing the data into an appropriate categories. Sometimes data is conflicting. For example, according one source of the data, Raj lives in Delhi, and second source says that Raj lives in Mumbai. So in the same case, there is a need to smooth the data by cleaning it. So now we'll talk about the types of data cleaning. Types of data cleaning, talking about the first we have is your missing values. In the terms of the missing values, that missing values are filled with appropriate value, and following are the appropriate approaches to fill the value as well. The first approaches is that the tuple is ignored when it contains the several attributes with the missing values, and the second is the value that are filled manually for the missing value. The third is and the same global constant is used to fill the values as well, and the fourth is that the attribute mean is used to fill the missing values, and the fifth is that the most probable value is used to fill the missing value as well. The second we have is your noisy data. In the term of the noisy data here, that the noise in the random error or a variance in a measure are the variable, that following are the smoothing technique to handle the noise. So first in the noisy data, as I told you yesterday that in the last classes, that this is the first one is your binning technique. And in the today class, in the starting, I had told you about the binning technique as well. In the binning technique, that this method smooths out the sorted data by consulting the neighborhood value around the noisy data as well, and that the sorted values are distributed into bins, and because binning method consults the local neighborhood, and they do local smoothing as well. So the second here is your clustering. In the terms of clustering, that clustering helps in identifying the outlier and the similar value that are organized into the clusters, and those values which fall outside the cluster that are called the outliers as well. Talking about the third one here in the terms of noisy data, that we have your combined computer and a human inspection. Combined computer and human inspection. In the terms of combined computer and a human inspections here, that the outliers that can also be identified with the help of the computers and a human inspection, the outlier pattern that can be informative are the garbage, and that the patterns have surprise value that may be output to a list, and the humans that can sort out to the garbage pattern and that can be excluded subsequently from the data mining as well. Talking about the D1, which is your regression. In the terms of the regression here, that smoothing of the data that can be done by fitting the data to the regression function, and for two variables, that is your linear regression is suitable, while for multiple variables and the multiple linear regressions, which is an extensions of linear regression, that is used here. Talking about another one, that is the third one. The first we had talked about missing values, the second is your noisy data, and the third one is your inconsistent data. So the third we have, that is your inconsistent data. In the terms of inconsistent data here, that the inconsistency that can be recorded in some transaction during the data entry or arising from integrating the data from the different database, some redundancies that can be identified by the correlation analysis, and careful and a proper integrations of the data from a multiple source that can reduce and avoid redundancy as well. Talking about the another one, which is your another question, what is clustering and regression, and explain with a suitable example. So let's go ahead to discuss about the clustering in a detail and the types of the clustering, the various approaches of the clustering as well, and then talking about the regression here. So let's go ahead. The another topic we have is your clustering. In the terms of clustering here, that the clustering technique consider the data tuples as the data objects, and they partition that the partitions these data objects into the groups of the cluster, so that the object in a cluster are similar to another and are dissimilar to objects in the other cluster as well. In the same case, talking about it, that the quality of a cluster that may be represented by its diameter and the maximum distance between any two objects in a cluster, that in a data reduction, that the cluster representations are used to replace the actual data, and the effectiveness of this technique that depends on the nature of the data and the various approaches of the clusterings that we'll discuss here, and the various approaches we have here, that is your hierarchical clustering. In the term of hierarchical clustering, that has been divided into two. The first we have is your, that is agglomerative, and the second we have, which is divisive. So this is the two hierarchical clustering here, that is agglomerative and divisive here. The second we have is your this partitional clustering. In the partitional clustering, and third we have here is your categorical clustering. So these were the three types of clustering here. In the same case, for example, that the customer related to a particular city, that three data cluster that can be defined, each cluster centroid is marked with a plus, and that is your, in the same case, that representing the average point in the space for that cluster. The outlier may be detected as a value that fall outside the sets of the cluster as well. Now talking about the regression here. In the term of the regression here, that a regression model is used for approximations of the given data, and in a linear regression, that the data are modeled to fit a straight line. For example, a random variable y that can be modeled as a linear functions of another variable x with an equation as well, which is we have an equation that is termed as y equals to alpha plus beta x So in the same case here, that where the variance of y is assumed to be constant and the coefficient of alpha and beta, that known as a regression coefficient, that specifies the y-intercepts and the slope of the line respectively, and the coefficient that can be solved by the method at least squares, which minimize the error between the actual and the estimate as well. Now talking about the another question here, and that is we'll deal with it, and that is to describe in the brief the process of data integration and transformation. So first we'll discuss about the data integration, and then we'll discuss about the data transformation here. In the terms of the data integrations here, it combines the data from a multiple source into a consistent data source, such as in the data warehousing. The source includes various database and the data at the cubes, flat files, etc. The following issues are required to be considered for the integration of data. That the schemes integration is very tricky. For example, matching the entity identification, which is employee ID, in one database and employee number, that is in the next database here, number in another database as well. Such problems that can be avoided using the metadata as well. In the same case, that the redundancies that are identified using the correlational analysis and the detections and the resolutions of the data value that conflicts, such an attribute value of same entity from a different source that may differ, and for example that the price value of the different hotels that may be in a different currency units, in order to reduce and avoid the redundancy, and that careful integrations for a multiple source that must be done as well. Now I'll talk about the data transformation here. So here we'll go ahead with the data integrations here, and that even though we had discussed, now we'll talk about the data transformation. So here we'll talk about the data transformations here. So in this, that it consolidates the data into the appropriate the forms for mining, and the process that involves the following steps as well. And the first step is that smoothing means that removal of the noise from the data, and that the aggregations means that the summary of aggregation operating for an aggregating data as well, and in the generalizations works to make low level primitive and the higher level concept using the concept hierarchies. We're talking about the normalization in the terms of the data transformation, that the attribute data that are scaled so as to be filled within the small specified range, for example minus 1.0 to 1.0 or 0.0 to 1.0. That in attribute a construction step, that a new attribute is constructed and added from a given set to the help the data mining process as well. Now we'll talk about the another one, and that is your the score, that is Z score normalization. Z-score normalization, which is of marks 5, and in the type of the normalization, that the mean of the transformed set of the data points is reduced to 0, and for this, that the mean and the standard deviations of the initial set of data values that are required, and the transformation formula is to be as follows here: dash equals to b minus a bar upon a. So here the a bar and that is your that are the mean of the standard deviations, that the initial data values, and for example if the average income is 54,000 and that is your income is 16,000, then of course the v is 76,000 start transformed to, and that is the v dash is 1.375. So this is the useful when the actual minimum and maximum values of the attributes are known here. Now we'll talk about some of the related things in the terms of the data reduction, and that what we talk about it. So let's go ahead. Data reduction. In the term of the data reduction here, that talking about, before starting with the data reduction, we'll go ahead with the short deep here in the terms of it, and that is in the terms of data reduction, that to select the data from a large data warehouse for the analysis, and it takes a very long time to process the data, which makes it impractical, and the data reduction Case of the data reductions that to select the data from the large data warehouse and for analysis, and it takes very long time to process the data, which makes it impractical. And the data reduction is used to obtain or reduce representations of the data in small values by maintaining the integrity of the original data as well. In the terms of the methods of data reduction, that also we'll talk about in a detail, and that is your data cubes. Aggregation is the first method, and we will talk about the aggregation operation are applied to the data in the constructions of the data cube as well. And the second is that the attribute subset selection, which is irrelevant, weakly relevant, or redundant attribute that are detected and removed as well. The third is your dimensionality reduction, which is encoding is applied to obtain a reduced representations of the original data. And the fourth we have is your numerosity reduction, which is your data are replaced by the alternative smaller data representations. And the fifth we have is the data compression, which is data is compressed so as to reduce the size of the storage of data as well. And in the same case for the sixth one, which is your discretizations and concept hierarchy, so there are data values for the attribute that are placed by ranges or higher conceptual levels as well. And the seventh we have is your decision tree, which is it is a flowchart like a tree structure where each internal node to is a test on an attribute and a branches outcome of the test as well. So here in the so on that we'll talk about in a detail as well. And in the same case, talking about the another one which we have here is that medium answer type questions and the long answer type questions. So the question is that another question is, what do you mean by a data reduction, as I told you about and explain the types, so that we'll talk about in this class only. So in the data reduction, that the data mining is applied to the selected data in large amount of database. When data analysis and mining is done on a huge amount of the data, then it takes a very long time to process, which makes it impractical and infeasible. And to reduce the processing time for a data analysis and data reduction technique that are used to obtain a reduced representations of the database that is much smaller in volume by maintaining the integrity of the original data. By reducing the data, the efficiency of the data mining process is improved, and which process the same analytical results as well. Now talk about the types of data reduction. In the types of data reduction here, that for the first type we have is that is the data cube aggregation. Data cube aggregation is this, that in this method that the aggregation operations that are applied to the data in the constructions of the data cube as well. The second we have here is your attribute subset selection. In the attribute subset selections here, that in this method the irrelevant, weakly relevant, or a redundant attribute that are detected and as well as removed. The third we have, that is dimensionality reduction. In the dimensionality reduction, that encoding a mechanism and used to reduce the data set size as well. Fourth we have is your numerosity reduction. Numerosity reduction in this, that the data are replaced estimated by alternative the smaller data representations, and as a such as a parametric model or a non-parametric model, that like clustering, sampling, and the use of the histograms as well. Talking about fifth one, which is discretization and concept hierarchy generalization, that is your generations as well. So in this method, that the raw data values for the attribute that are replaced by range or a higher conceptual level, that they allow a mining of data at a multiple level of abstraction as well. I'll talk about the another one in a detail, and that is comes under in it. But that is, what do you mean by a data cubes aggregation? The data cube aggregation here in this, that when we have a data in the form of the data different from the needed, then the aggregation method that can be applied to the attribute to obtain the desired attribute. For example, here a shop has a data consist of its quarterly sales for the year, that is 2010 to 2012, and the data is available in the quarterly form, but there is a need to retrieve its annual sales, and so we need to aggregate the data to find the desired output. Here we have year 2010, we have a quarter and then we have a sale. In the first quarter of 2010, that is your 1000 sales, and then the quarter second, that we have 50,000, quarter third we have 40,000, and quarter four that we have 30,000 sale in 2010. In 2011, that is your quarter first, we have 8,000 sales, quarter two that is 15,000 sale, quarter three that is 10,000 sale, and quarter four that is 20,000 sale as well. In the year 2012, where we have quarter one that is 15,000 sale, quarter two 20,000 sale, and as well as quarter three 40,000 sale, and quarter four that is your 30,000 sale as well. So here in the next coming the sales per quarter, if I'm talking about here, and that is in the terms of it. So here in the same case for that the sales per quarter from the year 2010 to 2012, that gets aggregated into a single annual sales record as well. So here in the year that 2010, we have 1,30,000 sale, and 2011 that is here we have 53,000 sale, and 2012 we have 1,05,000 sale here as well for the annual sale that we are counted out. Let's go ahead to another one, and that what we have to discuss about it, like explain attribute subset selection method for the data reduction with an example. So let's go ahead to discuss about it, attribute subset selection. In the terms of it, attribute subset selections here, that there may be a possibility of the irrelevant attribute or the redundant data in the data set, which are irrelevant for the data mining task, and the resultant data patterns of such data sets are of poor quality and slow down the data mining process due to the redundant data. The attribute subset selection that reduce the data set size by removing such redundant or irrelevant attribute from it, and the basic technique of the heuristics method for the attribute selections are. So here the first we have is your, that is stepwise forward selection. So stepwise forward selection in this, that in this procedure, the best of the original attribute that are selected and added to an empty set, and this is an iterative approach. At each step, that the best of the remaining original attribute that are added to the set. For example, the initial attribute set we have the A1, A2, A3, A4, and A5, and A6. That the initial reduced set we have A1, A1, A4, a reduced attribute set which is A1, A4, and A6 as well. We're talking about the second one we have, which is your stepwise backward elimination. In the stepwise backward elimination, this procedure starts with a full set of attributes, and at each step it removes the worst attribute that is remaining in the set. For example, the initial set attribute we have is your A1, A2, A3, A4, A5, and A6 as well. In the same case, talking about it, that we have A1, A3, that is your A4, A5, and A6, and A1, that is your A4, A5, A6. The reduced attribute set we have is your A1, A4, and A6 as well. Talking about the third one here, that is a combination of forward selection and a backward elimination here. So let's go ahead here. forward selection and backward elimination. So combination of forward selection and a backward elimination, if I'm talking about here, so that we have to talk about it. And in this, this procedure will work by combining the stepwise forward selection and a backward elimination at each step, and that the procedure selects the best attribute and that remove the worst from the remaining attribute as well. Let's go ahead with the fourth one, which is that is the decision tree induction. In the decision tree induction, in this method, a tree is constructed from a given data and a flowchart is constructed to take decision, and that the node denote a test on an attribute, branches that represent the results of the test, and leaves denotes class prediction as well. For example, the initial attribute said we have A1, A2, A3, A4, A5 and A6 as well. So that we'll be having a classes in the decision tree, and that is the reduced attribute. We'll find it out A1, A4 and A6 as well. So let's go ahead with another one, and that's what we have to discuss here. Now we'll discuss about it, that is your dimensionality reduction. In the terms of the dimensionality reduction, this is another question, and that is write a short note on dimensionality reduction, which is of 5 marks. In this process, the data encoding or the transformation that are applied to obtain a reduced representation of the original data, and if the original data that can be reconstructed from the compressed data without any loss of information, and that the data reduction is called lossless. If the data reconstructed is only approximated of the original data, then the reduction is called lossy, and there are the two methods of the lossy reduction. The first we have, and that is your wavelet transform. In the wavelet transform here, that is the linear signal processing technique, and the second is your principal component analysis. In the principal component analysis here, it searches for the K and that dimensional orthogonal vector that can be best used to represent the data as well. Now we'll go ahead with another one which we have to discuss about it, which is explain principal component analysis in detail, and that has been asked many times, and which is known as the pre-CA as well. So let's go ahead to talk about it in detail. Talking about here, this is your principal component analysis. In the term of the principal component analysis here, that is searches for the K and dimensional orthogonal vector that can be best used to represent the data where K is less than equals to N, and that the original data that are projected onto a much smaller space, and which results in the dimensionality reduction. It combines the essence of attributes by creating an alternative smaller set of variables, and even though the initial data that can then be projected onto this similar small set, and following are the steps which are used in PCA. So there are the steps that is talking about the first step, which is that the input data are normalized so that each attribute falls within the same range, and this steps ensures that the attribute with a large domain that will not dominate the attribute with smaller domains as well. In the second step, that is the PCA, that computes the k-orthogonal vector that provide a basic for the normalized input data, and these are the unit vectors that each point in a direction perpendicular to the others, and these vectors are called principal component, and the input data that are linear combinations of the principal component as well. Talking about the third one which we have here, the third steps is that the principal component are sorted in order of decreasing strength, and the principal component essentially serve a new set of access for the data that providing important information about the variance as well. And that the fourth is that because the components are sorted in decreasing order of strength, that the size of the data that can be reduced by variance and using the strongest principal component, and it should be possible to reconstruct a good approximation of the original data as well. So we'll talk about PCAs, this is by 1 by 2 and the first two principals component of the given data, and that we have here as follows. This is x2 axis, this is x1, this is your y1, and this is your y2. So these were the axes forming an ellipsoid form of figure. And now we'll talk about another one, and which we have here is your that what do you mean by numerosity reduction? So what do you mean by the numerosity reductions here? In this, that in the numerosity reduction, the data volume is reduced by choosing the alternate smaller forms of data representation, and this can be the parametric or non-parametric for the parametric method, and a model is used to. In the same case, for this, as we had gone in a detail as well, so where that estimate that the data, so that the only the data parameter that used that need to be stored, and that instead of an actual data, for example the log linear models, non-parametric methods are used for storing the reduced representations of the data, which include the histograms, clustering, and sampling. And following other technique, that is the numerosity reduction, includes. So the first technique talking about here, and that is the regression and log linear models. Regression and log linear models. In this same case, that these models are used to approximate the given data, and in linear regression, that the data are modeled to fit a straight line. For example, a random variable y can be modeled as a linear functions of the another random variable x, and with the equation that we have y equals to x plus b, and where the variance of the y is assumed to be constant, like log linear models approximate is the discrete multidimensional probability distribution. The second we have is your histograms. In the term of the histograms use of binning to approximate the data distribution, and a histogram for an attribute A that partition the data distribution of A into a disjoint subset or bucket. If each bucket represents only a single attribute value, then the bucket are called singleton bucket here. Talking about the third one, which is your clustering. In the term of the clustering here, that they partition the object into the groups or clusters, so that the objects within a cluster are similar to one another and similar to the other objects in the other cluster as well. Now talking about the fourth one, which is your sampling. In the term of sampling here, that it allows a large data set to be represented by a much smaller random samples of the data as well. So this has been represented here. Now I'll talk about a question here which where the question has been asked, explain histograms. So as we had discussed about the histogram, that histogram is a binning that to approximate the distributions, and a histogram for an attribute A that partition the data distributions of A into a disjoint substrate or a bucket, and if each bucket represent only a single attribute value, then the bucket are called singleton bucket as well. Now we'll do a question. That the question is that the following data are a list of prices of commonly sold item at a company. So the numbers that have been sorted is 1 1 5 5 5 8 8 10 10 15 15 15 20 20 20 20 20. You have to make a histogram for a price using a singleton bucket. This is of 5 marks. So histogram, as I explained you. So let's go ahead to draw a histogram for this particular data. First, we'll go ahead with the question. So the question we have, following data are the list of the prices of commonly that is sold in items in the company, and that the number have been sorted which is your 1 1 5 5 5 8 8 10 10, and then we have 15 15 and 15, then we have 20 20 and 20 and 20. Make a histogram for price using singleton bucket. So here we'll go ahead with solution. So let's draw us that histogram here. One, two, three, four. These were that has been represented is your, that is your count, and these were prices, and that has been named as 2 4 6 8 10 12 14 16 18 20. So here in this, that for the one we have to, that is your one, आपके दो हैं, तो let's go ahead with 2, and then we have sorry, that one is 2, and then we have 5. So 5, for how much we have 1 2 3, so that will goes to the 3 here. So 5 will goes to the 3. Then we have 8, that is 2, so 8 is here, and that is your 2, so it will go to 10 is also 2, so 10 is also goes to the 2. 15 is 3, so 50 is here, that is your 3, and then we have 20, that is your 4, so 20, that is your 4, that is enough. So this is a histogram that has been made here. Let's go ahead with the further one, and that you have to draw as well here as well, and let's go ahead to discuss about it, which is the another question, and that is your distinguish between dimensionality reduction and numerosity reduction here. That has been asked many times in an examination paper of 5 marks. Difference between dimensionally reduction and numerosity reduction. So in this we have many multiple points to discuss about in the differences between, and that has been asked many times, so this is very important as well. In a dimensionality reduction, that the data encoding or a transformation that are applied to us to obtain a reduced or a compressed representations of original data. And in the reduction, that in the reduction, the data volume is reduced by choosing an alternative smaller form of the data representative as well. In the dimensionality reduction here, that the method for the dimensionality reduction is direct wavelet transform and the principal component analysis. In the method of numerosity reduction, which is the regressions in a log linear model, which is parametric, or a histogram clustering sampling, that is non-parametric as well. The third difference we have is here that it can be used for removing irrelevant and redundant attribute, and it is merely a representation technique of original data to smaller form. In this method, some data that can lost, which is irrelevant, and in this method there is no loss of data, but whole data is represented in a smaller form as well. So these were the four differences between dimensionality reduction and numerosity reduction as well. Let's go ahead with the detail, and that what we have to discuss about it, which is write a short note on a discretization. Discretizations here, talking about this, that the cretization technique that can be used to reduce the number of the values for a given continuous attribute by dividing the attribute into a range of the intervals, where the interval values, that label that can be used to replace an actual data values, and these data are typically recursive, and the large amount of the data that is spent on sorting of data at each steps, and many discretizations technique that can be applied recursively in order to provide a hierarchical or a multi-resolution partitioning of the attribute value, that is known as the concept hierarchy as well. In the same case, talking about it, let's go ahead with the detail, that is write a short note note on a concept hierarchy and its importance in data mining. So in the terms of the concept hierarchy and importance in the terms of data mining, that we'll discuss here. Concept hierarchy and importance in data mining. So in this, the concept hierarchy and its importance in the data mining, where the concept hierarchy maps at a lower level concept and to the higher level concept, and it can be represented in the form of the nodes in a tree like structures, and where each node represents the concept, or in the form of the lattice, or that can be in a partial order as well. This concept allows data to be mined at a multiple level of abstraction. It also provides the structures on which the data that can be generalized, rolling up, and specializations of the data that is drilling down, which allows the users to view the data from the different perspective and gaining further insight into the relationships hidden in the data as well. We are talking about the generalization of the data that allows the viewing data at more meaningful and explicit abstraction, and it makes the data easier to understand, compresses the data, and require fewer input and output operation as well. While in the specializations of the data, concept values are replaced by the lower level concept and may have more than one concept hierarchy for a given attribute, and that are dimension based on a different user viewpoints as well. Now we'll talk about the another one, which is your discuss the techniques of the discretizations and the concept hierarchy generalization for the numeric data here. So that we'll discuss here in the detail. in this that it is difficult to specify the concept hierarchy for the numerals attribute due to the wide diversity of the possible data range and a frequent update and data values. That the methods of the concept hierarchy generalization by numeric data are: the first we have is your binning. In the term of binning, that the attribute value that can be distributed by distributing the value into bin and replacing each bin value by the mean bin and value and a bin median value as well. The second we have is the histogram analysis. In the histogram analysis, that the histogram analysis algorithm that can be applied recursively to each partitions in order to automatically generate a multi-level concept hierarchies. And in the same case, we're talking about it here that partitioning rule that can be applied to define the ranges of the values as well. Talking about the third one, which is your cluster analysis. In the term of the cluster analysis here, that this algorithm that can be applied to the partition data into the clusters or the groups. Each cluster forms a node of a concept hierarchy and where all the nodes are at the same conceptual level here. So let's go ahead with another one that we have to discuss the technique of discretizations and the concept hierarchy generalization for the categorical data here. By the categorical data here. So here the categorical data that are discrete data with a finite number of discrete values with no ordering among the values such as geographical locations, item type and job category. The method of the concept hierarchy that can be a categorical data that are as to be followed. The method of the concept hierarchy for categorical data, that is the first we have is just specification of a partial ordering of attribute explicitly at the schema or level by export. Specification of a partial ordering of attributes, that is explicitly at the schema level by exports. So in this talking about here, that is this procedure requires a group of attribute and the expert that can easily define the concept hierarchy by specifying a partial or the total ordering of the attribute of the schema level here. The second we have is just specification of a portion of a hierarchy by explicit data grouping. In this, normally in a large database that it is not possible to define an entire concept hierarchy by explicit value definition, but it is important to specify the explicit group for a small portions of data here. Now third one we'll talk about it, which is a specification of only a partial set in this, it is possible that the user might have a vague idea of what is required to be included in the hierarchy. For example, that the username may specify only first and the last name and not include the middle name. Now, such partially that specified hierarchy is handled by embedded data semantics and the database schema for pinning together the attribute with the tight semantic connections as well. Now we'll talk about with the another one, which is the another question, and what do you mean by data mining, and differentiate between the data mining technique and a data mining strategy here. So that is the data mining we had discussed about in a detail many times here. Now we'll discuss about some of the related things, which is your data mining technique. In the data mining technique here, where the technique that used in the data mining, that are analytical and a mathematical algorithm and is applied to a business problem to extract the pattern from the collected data within the databases of the organization, and the business experts that can also easily use these tools because of its GUI feature. Some of the data mining techniques are like artificial neural networks, genetic algorithm, nearest neighbor, induction rule, clustering and decision tree, etc. that comes under the data mining technique here. Now we'll go ahead over the further one, and that what we have to discuss here as well. And in the same while, when we'll go ahead here in the detail, and that is comes under the data mining strategies. In the data mining strategies here, the data mining activities that can be categorized into the predictive data mining and a descriptive data mining. The first data mining technique that strategies we'll talk about, the first is your predictive data mining. In the predictive data mining, which produces the model of the system that is described by the given data set in order to make a prediction as well. The second we have here is your descriptive data mining. In the descriptive data mining here, that which provides a new non-trivial information that is based on the available data sets. So going ahead here in this, so where in the same cases that on a predictive end of the spectrum, that the goal of the data mining is to produce a model that is expressed as an executable code which can be used to perform a classification, prediction, estimations or the other similar tasks. And on the other hand, that the descriptive end of the spectrum of that the goal is to gain an understanding of an analyzed system, that to try to uncovering the pattern and relationships in a large data act as well. So the data mining strategies has been divided into two, which is unsupervised learning and supervised learning. And unsupervised learning has been divided into two, which is association clustering rule, association rule and the clustering here. Supervised learning has been divided into three, which is a classification, estimations, and predictive here. So let's go ahead to discuss. This is the data mining strategies. Let's go ahead to discuss about the another topic, which is your write a short note on a social implications of data mining, and which is also has been asked of 5 marks. Social implication of data mining. And the social implications of data mining, if I'm talking about here, and the social implications of the data mining here, that the data mining technique that have become a common for an organization and are used in the normal day-to-day activities, such as how we shop, work, search for information, and that can even influence the time and health and well-being as well. The business has become more efficient through the use of the data mining activities. Data mining is application that can derive much demographic information concerning the customers that was previously not known or hidden in the data. Many companies that use the data mining for the customer relationship management, that is your CRM, which helps to provide more customized personal services addressing an individual customer's need by studying the browsing and purchasing the patterns of the customers as well. In a Google search engine, when I will talk about it, so when some keywords for the topic of interest is typed, like Google return to a list of websites that is related to that keyword, and it core of the Google web mining technology here. As increased interest in the data mining technique that led to its the use in the various applications like the fraud detection, identifying criminal suspects, developing the drugs to find association between the patients and the drugs and outcomes, and predictions of the potential terrorist as well. The approach that is often used in one of the profiting the typical behavior of our characteristics involved. It can be done by identifying the attribute value that can commonly occur for a target class as well. Now we'll go ahead with the detail, which is your write a short note on a data mining metrics. Data mining matrix, that has also been asked 5 marks here. So data mining matrix, when we talk about it, which is your data mining matrix are some parameters or the measures of quantitative assessment used for the measurement or comparisons in the given data. These matrices helps in determining the efficiency of the data mining technique and help to take the right decision to choose the right data mining algorithm technique. Data mining metrics generally fall into the category of the accuracy, reliability, and the usefulness. Accuracy is the measure of how well the model correlates an outcome with the attribute in the data that has been provided as well. In the term same case, I'll talk about the reliability. So the reliability assess that the way that the data mining model performs in different data sets as well. In the same case, we'll talk about this in a detail. So here in that the data mining model is reliable if it is generate that the same types of protections that to find the same kind of pattern, and regardless the test data that is supplied. Usefulness that includes the various matrices that tell us whether the model provides the useful information, different matrices that could be used for a different technique and also based on the interest level as well. Whereas we use useful perspective of measures such as return on investment, which is ROI, that could be used for determining the differences between what is the determining cost and what is the saving or benefits for its use are here. What were the from that benefits from its use are here, and that it could be measured as increased sale, reduced advertisement expenditure, or both. The matrices that are used to guide the data mining algorithm here in the same, and to evaluate the results of the data mining. For example, when using a decision tree algorithm to solve a classification task, information gain may be used to guide the constructions of a decision tree, while accuracy may be used to evaluate the performances of the final tree as well. These matrices looks into the characteristics of the data sets such as number of classes, attribute and example, distributions of training examples in the example space, and level of the noise and the mixtures that continuous and a nominal value as well. Now we'll talk about some of the things, and hopefully this will be the last question that is possible with reference towards the data mining, with reference towards this unit which we have is your data mining and reduction. Hopefully we'll end up with this, and in the next coming class we'll start with the fourth unit as well. The question is, explain the algorithm for the classification and the decision tree induction, which has been asked of 10 marks. And the other question is that what is decision tree, and explain the classification of decision tree inductions, and explain describe the three pruning as well. So let's go ahead to discuss about each and everything. First we'll discuss about decision tree. In the terms of the decision tree, then when we are talking about here in the terms of decision tree here, that the decision tree that works like a flow chart, and it looks like an upside down tree, and the nodes that is representing the test and the decisions, and the lines or the branches that represent the outcome of the tree of the test, and that the circle are terminal leaf node, and the root node is the top and the starting node of the rectangle, and the terminal node as well. In the same case, that algorithm for the decision tree induction is a greedy algorithm that constructs the decision tree to the top-down recursive divide the computer manner as well, and in the same conquer manner as well, and that the tree starts with a single node that is representing the training that simples, and if samples are also at the same class, then the node becomes a leaf and is labeled with that class. Otherwise, the algorithm that uses an entropy that is based on the measure that known as information gain as an heuristic for the selecting the attribute that will best separate the sample into individual class, and this attribute becomes the best attribute at the node. And in this version of the algorithm, that all attributes are the categorical, that is to discrete values, continuous values attribute that must be discretized as well, where in the same case a branch is created for each known value of the test attribute, and the samples that are partitions accordingly. The algorithm uses the same process recursively to form a decision tree for the samples at each partition. Once the attribute that has been occurred at the node, it need not to be considered in any of the node that is your that descendants as well. So let's go ahead to discuss about tree pruning. In the tree pruning here, that the decision tree that can contain many branches which will reflect the here that many branches that which will reflect the anomalies in the training data, that due to the noise or the outliers, and the method that address this problem of overfitting the data. Such method typically use a statistical measure to remove the least reliable branches, that is resulting in the faster classification and the improvement in the ability of the tree to correctly classify the independent test data as well. In the talking about following are the two approaches of we'll talk about the approaches of tree pruning. So in the approaches of tree pruning, we have there are the two approaches. The first approach we have here is your that is tree pruning approach. In the pre-pruning approach here, that the tree is pruned by the halting its construction early, and that upon halting that the node become a leaf, and the leaf may hold the most frequent class among the subset samples or the probability distribution of those samples as well. In the same case, the second we have here in the same case, that is the second one is your post-pruning. This is a pre-pruning approach, and this is your post-pruning. In the post-pruning here, that it removes the branches from the fully grown tree, and a tree node is pruned by removing its branches, and the cost complexity pruning algorithm is an example of the post-pruning approach. The lowest unpruned node that becomes a leaf node and is labeled by a most frequent class that's among in the form of branches as well. So here this is the end of the unit 3, which we had completed the data mining and the reduction. In the next coming class we'll start with your that is your in the same case about it which is your that is in the terms of unit 4, and that is of 7th class as well. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button, and please like, share and subscribe our channel so that many maximum people can get the information at once, and even though you can also enjoy the video as well. In this we had completed the unit 1, and which is in the unit 1 we had covered up the data warehousing, and where in the data warehouse we had covered up the overview, that definition, data warehousing components, building a data warehouse, database, mapping a database, a warehouse, and the multiprocessor architecture, difference between the database system and the data warehouse, multi-dimensional data models, data cubes, stars, snowflakes, and fact constellation, concept hierarchy, process architecture, 3-tier architecture, and data mining as well. In unit 2, which is your data warehouse process and technology, this is your warehouse strategies, warehouse management and support process, warehouse planning and implementation, hardware and operating system for the data warehouse, client server computing, model and data warehousing, parallel processors and the cluster software systems, and distributed DBMS implementations, warehouse software, warehouse schema designs, and data extraction, cleanup and transformation tool, warehouse metadata as well. In unit 3rd, which is we had completed, which is your data mining and reduction, in this we have to cover up overview, motivation, definitions and functionality, data processing, that is forms of data pre-processing, and data cleaning, missing values, noisy data, binding, clustering, regressions, computers and human inspections, inconsistent data, data indication and transformation, data reduction, data cube aggregation, dimensionality reduction, data compression, numerosity reduction, discretizations and concept hierarchy generalization, and decision tree as well. In unit 4, which we have to cover up, start with the next class, that is your classification and clustering, where we have to cover up the classification, definition, data generalization, analytical characterization, analysis of the attribute relevance, mining, class, that is your class comparisons, statistical measures in the large database, statistical based algorithm, distance based algorithm, decision tree based algorithm, clustering, that is introduction, similarity in the distance measured, hierarchical and partitional algorithm, hierarchical stack clustering, cure and chameleon, density based method, DB scan optics, grid based method, sting click model based method, statistical approach, association rule, introduction, large item set, basic algorithm, parallel and distributed algorithm, neural network approach as well. In unit 5th, we have to cover up the data visualization. In this, that we have to cover up the aggregation, historical information, query facilities, OLAP function and tools, OLAP servers, rollup, molap, OLAP, data mining, interfaces, security, backup and recovery, tuning, data warehouses, that is testing data warehouses, warehouse applications, and the recent trends, types of warehouses, application, where mining is partial mining and a temporal mining. And then after that we'll start with discussing about very short type answers, which has been possible within these unit 1, unit 2, unit 3 and unit 4 and unit 5 respectively. So first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button, and please like, share and subscribe our channel so that many and maximum people can get the information at once. And even though you can also enjoy the video as well, and it will be provided each and every video which where we had to cover up the data warehouse and the data mining, the reasoning we are doing, the principle of programming languages, computer graphics, the PMS, the quantitative aptitude, and as well as the ecological your economics we are doing here. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you, please like, share and subscribe our channel. Thank you.